Good morning students. What was seen in the previous session? In the previous session I explained what are magnets, what is magnetism, and then what is electromagnetism, what is geomagnetism, what are the elements in earth magnetic field, and then what are the properties of magnets, that all are discussed in the previous session. In the today's session I will explain that magnetic field lines and Coulomb's inverse square law, and then axial line. Okay, inverse square law and axial line. Okay, that all will be discussed in this session. Then first, before enter the magnetic field lines, first I explain that pole strength. What's the meaning that pole strength? Pole strength is the strength in the one pole of the magnet. Always magnet are having the two poles, north and south pole. North pole having one strength and south pole having one strength. There the pole strength, what are the factors it will be depends on the pole strength. Pole strength எதெல்லாம் relate பண்ணி இருக்கும் அதான் பார்ப்போம். First pole strength dimension formula is M/0, L/1 and T/0 and A. What's the meaning that LA? This is the dimension formula for pole strength. And then unit for pole strength is Newton temperature per, so Newton time per -1 and ampere meter. This is the SI unit for pole strength. Then normally the pole strength will be depends upon the nature of the material and area. One magnet having some it will be made up of by some material, that the material type, and then what's the area of the material or what's the area of the magnet, and then some specific nature of the magnet specific nature. That all are, it will be relate the pole strength of the magnet. So the pole strength, it will be depend upon the type of material, and then area it will be cover the surface of the magnet, and some specific nature of magnets. That all are will be relate with the pole strength. Then sometimes magnet it will be cut into too many pieces. The magnet it will be act as each part of the magnet will be act as a new magnet, but the new magnet are having two poles also. Two poles only is there, no monopole exists. அதாவது ஒரு மேக்னெட்டை நீங்கள் எத்தனை தடவை உடைச்சாலும் all the pieces it will be act as an individual magnet. No to be having one, suppose one magnet it will be having you have to take one bar magnet. The bar magnet it will be split off into two, that is north pole, that is south pole. Just it will be depend upon, just it will be form the north and south pole and north and south pole. அதாவது ஒரு மேக்னெட்டை நீங்கள் எத்தனை தடவை ஸ்ப்ளிட் பண்ணாலும் அதில் நார்த் போல் சவுத் போல் இருக்கும். ஒன்லி நார்த் போல் மட்டும், ஒன்லி சவுத் போல் மட்டும் இருக்காது. ஸோ ஒன் மேக்னெட் இட் பி கட் இன் டு மெனி பீசஸ். ஆல் த மேக்னெட்ஸ் ஆக்ட்ஸ் as an individual magnet having the two poles, north and south poles. No monopole exists. Okay. Then suppose one magnet will be cut into, but one magnet will be cut into the horizontal motion. Pole strength it will be divided into two. Not to be divided into the two poles, but pole strength it will be divided into two. இது ஒண்ணா divide ஆகும். Pole strength it will be divided into two. But one magnet will be cut the vertical part. ஒரு magnet நீங்க vertical கட் பண்ணீங்கன்னா இது north pole and south pole. Pole strength it will be remains the same before the cutting or after cutting. Suppose one magnet will be cut into the horizontal motion or horizontal way, the pole strength it will be divided into half. But one magnet it will be cut in the vertical part, the pole strength will be remains same, not to be reduced to 2. ஒரு மேக்னெட்டை நீங்கள் ஹரிசாண்டலாக வச்சுட்டு கட் பண்ணிங்கன்னா போல் ஸ்ட்ரென்த் ரெடியூஸ் ஆகும், பட் வெர்டிக்கலாக கட் பண்ணிங்கன்னா போல் ஸ்ட்ரென்த் டிவைட் ஆகாது. ஓகே. தென் நோ மோனோபோல் எக்ஸிஸ்ட், ஆல்ரெடி ஐ டோல்ட். So according to the pole strength it will be the strength of the each pole of a magnet, one. And second one, pole strength dimension formula is M/0, L/1, T/0 and A. This is the dimension formula. And then SI unit of pole strength is ampere meter. Okay. Then pole strength will be depend upon the nature of the material, and then area of the surface of the magnet, and some specific nature of magnets. Then one magnet will be cut in the horizontal way, the pole strength will be reduced by 2. But in a vertical way, the pole strength does not to be reduced, it will be remains same. And then third one, no monopole exists. Okay, that all are the points that will be related with the pole strength. Now I will explain that magnetic field lines. Already you learned in the first lesson, that is electric field lines, that all the points will be same for magnetic field lines. Okay. So magnetic field lines, you have to take one magnet. The magnetic field lines, it will be always, this is the north direction, this is the south direction. In the outside, always the magnetic field lines will be start from north pole to south pole. Okay. So the outside of the magnetic field lines will be start from north pole and end at south pole. But inside the magnetic field will be moving to south pole to north pole. Okay. So outside of the magnetic field lines, it will be start from the north pole and end at south pole. But inside the magnetic field will be coming from south to north. Okay. This is the first point. Electric field lines will be start from north pole to, it will be end at south pole. And second point, the electric field lines, suppose one electric field lines you have to draw. Suppose you have to take tangent one line. Other tangent means in that line, your line you have consider that the line, it will be specify the direction of magnetic field. So you have to tangent at any point in the magnetic field lines, it will always gives the direction of magnetic field. நீங்கள் வந்து magnetic field line உடைய பாத்தில் எந்த இடத்துல நீங்கள் பாயிண்ட் பண்ணி பார்த்தாலும் it will be gives the direction of magnetic field. That is the second point. So first point, it will be start from north and end at south. Okay, that is the out, and inside it will be south to north. And then second point, so tangent, it will be give the direction of magnetic field. That is the second one. Third one, magnetic field lines never intersects. What's the meaning that never intersects? Suppose one line will be intersect with the another one line. Magnetic needle points the two direction at the same time. ஒரே டைம்ல magnetic needle வந்து ரெண்டு லைனை வந்து ஸ்பெசிஃபை பண்ண வேண்டியிருக்கும். This is not possible. So magnetic field lines, it will be just not to be intersect. So never intersects. This is the third point. Never intersect. Okay, never intersect. And fourth point, magnetic field lines, it will be crowd is one another. That's the point the magnetic field strength is strong. Magnetic power is strong when the magnetic field lines, it will be crowd with one another. எந்த இடத்துல magnetic field lines வந்து நெருக்கமாக இருக்குதோ அந்த இடத்துல magnetic power, it will be strong, or magnetic strength is strong. Then which the place the magnetic field, it will be loose with one another, that the point the magnetic field strength is weak. Okay. So crowd, the magnetic field strength is crowd, magnetic field strength is high, and some gap is there. Magnetic field lines is magnetic strength is low. Okay, ma? So there are the 4 points. The magnetic field lines. Magnetic field lines is important 3 mark. Magnetic field lines is always start from north pole to south pole. That is the outside of the magnet. So inside of the magnet, it will be moving south to north. And then second point, if you take the tangent at any point in the magnetic field lines, it will be give the direction of magnetic field. And third one, magnetic field lines, it will be never intersect with one another. And fourth one, magnetic strength, it will be strong if the magnetic field lines will be crowded with one another. Second one, magnetic field strength, it will be some gap is there. That the point the magnetic field strength, it will be low. Okay, this is all are the points in the magnetic field lines. And next one is Coulomb's inverse square law. Already you learned the Coulomb's law in electrostatics. What is the Coulomb's law? F, it will be directly proportional to Q1 Q2 by R square. This is the Coulomb's law in electrostatics. Okay, but in this session or in this lesson, the Coulomb's law is force of attraction or force of repulsion. What's the meaning that force of attraction and force of repulsion? Like you have to keep the two magnets. This is the north direction, this is the north direction. This is the north and south. So you have to draw near the north pole of one magnet and south pole of another one magnet. Attraction, it will be created. Attraction. Okay. But you have to keep the two magnets, north and north pole and south and south pole. You have to bring two same pole as well. The same pole it will be repulsive with one another. So you have to say like poles, it will be attracts with the Like pole, it will be repel with one another. Unlike poles, it will be attracts with one another. So, on the way, some of attraction is there or some of repulsion is there. So, force of attraction will be created or force of repulsion will be created. So you have to keep the two magnets. Suppose you have to keep the two magnets. You have to keep the two magnets, that is north and south pole. This is the south and north and south and north. You have to take the two poles of magnet. Some attractive force it will be created in between the two magnets. That the attractive force, it will be directly proportional to the pole strength of first magnet and pole strength of second magnet. Pole strength of second magnet by distance between the two magnets. Distance between the two magnets. That will be called as Coulomb's inverse square law. Okay. So force of attraction or force of repulsion, it will be directly proportional to the product of pole strength of first magnet and pole strength of second magnet and to the square of the distance between them. That is simply called as Coulomb's inverse square law. Okay, Coulomb's inverse square law. And proportionality will be removed by using one constant, that will be equal to K into QMA and QMB by R square. That will be called as mu naught by 4 pi. Mu naught by 4 pi, it will be equal to the 10 power minus 7. Mu naught by 4 pi. That the value is, K is mu naught by 4 pi. What is mu naught, ma? Mu is permeability. Permeability means which material will be allow the magnetic field to pass through them, it will be called as permeability. Mu naught is permeability in free phase. So 4 pi value is 3.14. So mu naught, K is equal to mu naught by 4 pi. The value is nearly equal to 10 power minus 7 Henry per meter. Henry per meter. The unit is Henry per meter. So, constant K is equal to mu naught by 4 pi is approximately 10 power minus 7 Henry per meter. So, force of attraction or force of repulsion will be directly proportional to the product of two pole strength of the magnet and to the ratio of, to the square of the distance between the two magnets. Then, proportionality will be removed by adding one constant, that is K, QMA, QMB by R square. Constant value is equal to mu naught by 4 pi and that the value of K is equal to 10 power minus 7 Henry per meter. This is the inverse, Coulomb's inverse square law. This is the same way we explain the universal, Newton's universal law and then Coulomb's law in electrostatics, and then this is Coulomb's inverse square law in magnetism. Okay, மூணு லாவும் ஒரே மாதிரி தான் வரும், terms மட்டும் மாறும். Okay, this is the inverse square law. Now I explain that magnetic field at a point along the axial line. You have to take one axial line. You have to keep one magnet. Okay, that the magnet that the magnetic field way, you have to draw one line. That the line it will be called as axial line. So magnetic field will be created at a point on the axial line. ஒரு மேக்னெட்டை வச்சுருக்கீங்க, அதுக்கு நேர ஒரு லைன் ட்ரா பண்ணியிருக்கீங்க, அந்த லைனில் ஒரு பாயிண்டில் மேக்னெட்டால் கிரியேட் ஆகக்கூடிய மேக்னெட்டிக் ஃபீல்ட். ஸோ மேக்னெட்டிக் ஃபீல்ட் இஸ் கிரியேட்டட் பை எ மேக்னெட் அட் த டூ போல்ஸ் அட் அ பாயிண்ட் ஆன் த ஆக்சியல் லைன். ஆக்சியல் லைனில் ஒரு பாயிண்ட்டுக்கு எப்படி கிரியேட் ஆகுது தான் கொஸ்டின். ஓகே, ஸோ ஃபர்ஸ்ட் யூ ஹேவ் டு ரைட் த ஃபார்முலா ஃபார் மேக்னெட்டிக் ஃபீல்ட். வாட்ஸ் த ஃபார்முலாமா? ஃபோர்ஸ் ஆஃப் அட்ராக்ஷன் ஃபார்முலா. வாட்ஸ் த ஃபார்முலா? FA. So first north pole எடுத்துக்கலாம். ஓகேவா? At a point north pole, then the magnetic field is created at a point C due to the north pole of magnet. North pole magnetல இருந்து அதாவது மேக்னெட்டோடைய நார்த் போல்ல இருந்து பாயிண்ட் C க்கு ஆட் ஆகக்கூடிய magnetic field. So before enter that, first you should mention the sign. You should know the sign convention for magnetic force is in between the two magnets. First you should take the positive direction. The magnetic force will be created from the north pole. North pole magnet la irundhu ஒரு magnetic force create ஆகுதுனா it will be taken as positive, but south pole la create ஆகுதுனா it will be taken as opposite direction of the magnetic field, it will be taken as negative. Okay, it will be, you should clear that first. So first the force will be created at a point C due to the north pole. Okay, the force will be created, the magnetic force will be created at a point C due to the north pole of the magnet. So what's the formula? K value is mu naught by 4 pi, mu naught by 4 pi, formula is Q pole strength of first magnet and pole strength of second magnet. So magnetic field only we want to know. So what's the magnetic field? Force by, what's the formula? Magnetic field is equal to force by pole strength. What's the force formula? Mu naught by 4 pi QA QB by Q null. So you do the cancel out. So any one. So mu naught by 4 pi 1 pole strength. So mu naught by 4 pi 1 pole strength is, you have to mention as Q or QA. Okay. Something you have to mention that is just is mentioned with Q, not to be QA and QB. So just is mentioned with QM, that is magnetic pole strength, QM. So mu naught by 4 pi QM into pole strength. So QM by R square. Okay, this is the magnetic field formula, mu naught by 4 pi QM by R square. Actually QMA QMB by R square, you know. So one pole strength, so QM by R square. This is the first equation we consider, but this is the R part. R part is the distance. So we consider as mu naught by 4 pi. So Qm by the distance is R. Now we calculate the distance. The distance between the two poles, it will be called as 2L. But the length L, it will be split of L and L. Or magnet the total length 2L. But L நம்ம பாதி பாதி எடுத்துட்டோம்னா the distance between the magnet and at the point C is R. Okay. So thus the point is total R. In the center point at the point C variable length R. Okay. So we mentioned with R that the minus L. நம்ம இங்க இருந்து இங்க வரைக்கும் வேணும். இதுல இருந்து இது வரைக்கும் R. So இந்த L அங்க divide பண்ணிக்கலாம். Sorry, subtract பண்ணிக்கலாம். So R minus L. So R it will be mentioned with R minus L the whole square. This is the first equation. Okay. Then second one, that is Fn. Now magnetic field at a point C due to the south pole. Due to the south pole, that is Fs is equal to mu naught by 4 pi Qm by R plus L, because இங்கே வரைக்கும் வரணும். So totally the length that will be between the C2 length, it will be between the C2 C point lerundu L varaikkum, sorry, south pole varaikkum, that is called R plus L. So R plus L the whole square. This is the second equation. So we want to know that total magnetic field. So total magnetic field F is equal to Fn plus Fs. We substitute the two formulas to mu naught by 4 pi. Mu naught by 4 pi it will be taken as, but the second south pole already I told that the magnetic force will be greater than south pole, it will be taken as negative. Okay. So mu naught by 4 pi it will be taken at outside. Qm by R square, R minus L the whole square minus Qm by R plus L the whole square. Clear ma? So Qm by R minus L the whole square minus Qm by R plus L the whole square. Taking Qm at the outside. Now Qm at the outside. How to calculate? Qm at the outside, the force, total net force F is equal to mu naught by 4 pi into Qm into 1 by R minus L the whole square minus 1 by R plus L the whole square. Okay. So taking the LCM R minus L and R plus L, mu naught by 4 pi into Qm R square minus L square. Okay. R square minus L square. Killer. R square minus L square the whole square. And numerator R plus L the whole square minus R minus L the whole square. Okay. கீழே a minus b the whole square இருக்குது, a plus b the whole square இருக்குது. ஃபுல்லாக நீங்கள் a plus b a minus b எல்லாத்தையும் நீங்கள் ஃபோட்டோ எடுத்தீங்கன்னா r square minus l square the whole square வரணும் நியூமரேட்டரில். நியூமரேட்டர் r plus l the whole square minus r minus l the whole square. a plus b ஃபார்மேட் படி நீங்கள் elaborate பண்ணுங்க. mu naught by 4 pi into r square plus l square minus 2OL minus r square plus l square minus 2RL. Okay, by r square minus l square the whole square. Clear ma? Then mu naught by 4 pi r square plus l square plus 2OL minus r square minus l square plus 2OL by r square minus l square the whole square. Clear ma? Then now the step it will be formed. Steps to be changed. Mu naught by 4 pi QM mu naught by 4 pi QM into r square cancel, l square cancel, balance 4OL by r square minus l square the whole square. Now taking 4RL, you have to split off into 2 into 2RL. 2 into 2RL, we consider R it will be greater than, very much greater than L. R the distance it will be very much greater than L. We have to neglect that R, L value. So mu naught by 4 pi QM, we consider 2 into 2RL. Okay, 2 into 2RL by the L square term it will be neglected, so R power 4. Okay, so R cancel, balance mu naught by 4 pi QM into 2 or QM into 2L that will be called as pole strength. So 2 mu naught by 4 pi pole strength PM 4 pi R cube. So 2 mu naught DM by 4 pi R cube. 2 mu naught by 4 pi இது எப்படி எழுதலாம்? mu naught by 4 pi 2 into PM by R cube. This is the final formula for magnetic field. It will be created not to be this not as a force, that is will be called a magnetic field. Magnetic field it will be mentioned as B. So B in North Pole and B in South Pole. It will be called as B in North Pole and B in South Pole. And then this is also you have to mention as magnetic field B, total magnetic field. So we consider as the total magnetic field it will be equal to mu naught by 4 pi 2 PM by R. So this is the final formula for a magnetic field. It will be created at a point C due to the magnet. Okay. So first we consider as one magnet having north and south pole. We draw one line according to the axis of the magnet. That the line it will be called as axial line. You have to decide one point on the axial line, that will be called as C. That the axial line, the point C point, the magnetic field created due to the north pole, due to the south pole you have to mention. So the magnetic field created due to the north pole is equal to mu naught by 4 pi QM by R square, and south pole mu naught by 4 pi QM by R plus L the whole square. The R value it will be mentioned as first R minus L, next mention as R plus L, because the total length R is in between a midpoint of the magnet to at a point C. Point C la the midpoint varaiku ulla distance R nu eduthukeenga. So we want to north pole to C point, that will be L R minus L. The total south pole to point C, that will be R plus L. Okay, we substitute the two equations in the formula. So total magnetic field it will be equal to mu naught by 4 pi QM will be taken as outside, 1 by R minus L the whole square minus 1 by R plus L the whole square. Taking the LCM, R plus L the whole square minus R minus L the whole square by R square minus L square the whole square varum. Then you have to elaborate A plus B the whole square and A minus B the whole square format. So mu naught by 4 pi into QM into R square plus L square minus plus 2RL minus R square plus L square minus 2RL varum. So all the term it will be cancelled except the 2RL plus 2RL. So that will be mentioned with 4 oral. So mu naught by 4 pi qm into 4 oral by r square minus l square the whole square. Then mu naught by 4 pi qm, 4 oral it will be split off into 2, 2 into 2 oral. So qm into 2l it will be called as pm. So mu naught by 4 pi 2 pm by 4 pi r cube. So this is the final formula for magnetic field. It will be created at a point C from the north and south pole of the magnet. Okay. So in the today's session I explained that what are the factors will be depend upon the pole strength. What are the points ma? First dimension formula for pole strength, unit of pole strength, and then what are the factors it will be depends on the pole strength. Then one magnet will be split up into 2 pieces or many pieces in horizontally. The pole strength will be divided into halves. Suppose vertically you have to cut it, the pole strength will be remain same. And then now what are the points, what are the properties of magnetic field lines? Magnetic field lines means never intersect. Then magnetic field will be start from north pole to end at south pole outside of the magnet. And inside the magnetic field lines it will be moving south to north. And then third one it will be never intersect. And second one you have to take the tangent at a point on the magnetic field lines. It will be almost it will be giving the direction of magnetic field. And then fourth point, the magnetic field it will be strong, then magnetic field lines will be crowded with one another. Magnetic field lines it will be moved with there some gaps. Magnetic strength it will be low. That all are the properties of magnetic field lines. Coulomb's inverse square law, force it will be directly proportional to pole strength of first magnet and pole strength of product of pole strength of first magnet and second magnet by 2 square of the distance between the 2 magnets. So QMA, QMB by r square, you substitute one constant to remove the proportional. So mu naught by 4 pi is a constant. Mu naught by 4 pi, mu naught is a permeability in free phase. Mu naught by 4 pi value is 10 power minus 7 Henry per meter. Then we calculate the magnetic field at a point C in the axial line. That all are discussed in the today's session. So the home assignment for today's session is learn and write properties of magnetic field lines. First one. Second one, learn and write the magnetic field at a point along the axial line. Students, note down the homework. First one, learn and write the properties of magnetic field lines. And second one, learn and write the magnetic field at a point along the axial line. Okay, thank you.